When Python evaluates one call sitting inside another, how does it keep every variable straight? The answer is the environment model. Each function call opens its own private scope. Today we hand trace a single nested example all the way down and back up, watching scopes appear, resolve their names, and disappear. Here's the program. We define do twice with two parameters, n and fn. Its body returns fn of n, so the second input, fn, is called as a function inside the body. That tells us immediately fn must be a function when we call do twice. Below, we call do twice with two arguments, the number 3 and an anonymous lambda that takes x and returns x squared. So n maps to 3 and fn maps to that lambda. The print statement will display whatever the whole call returns. Let's trace it. We run this the way every trace works. Create a new environment for each call, map arguments to parameters, then evaluate the body. Python starts by building the global environment. In it, do twice is bound to a function object, and the print statement waits to display a result. Reading left to right, the first thing that happens is the call to do twice. Every function call begins by creating a new environment, so we open a fresh scope for do twice. Inside it, we bind the parameters. N maps to 3 and fn maps to the lambda that squares its input. Now we evaluate the body, return fn of n. But fn is a function call, and whenever we meet a function call, we must open a new scope before we can go any further, so do twice can't return yet. It hits the outer fn call first, and we open a new environment for that outer call to the lambda. Its parameter is x, and x maps to the argument inside it, which is fn of n. Do we have that value yet? No, because fn of n is itself another call. So this outer lambda scope is put on hold, and we open yet another scope. This innermost environment belongs to fn of n, the same lambda called again. Here x must map to n, but this scope doesn't know n. Nothing local defines it. So we look upward to the environment that does know n, the do twice scope, where n is 3. This upward search is how Python resolves any name. It climbs through the enclosing scopes until it finds the one that defines the variable. That 3 flows down, so here x is 3. Now this call can finish. It returns x squared, which is 3 squared, 9. It hands 9 back to whoever called it, and this innermost scope disappears. That 9 now replaces fn of n as the input to the outer lambda call, the one we left waiting. Its x is now 9, so it returns x squared, which is 9 squared, 81. That call is finished, and its scope disappears too. Here's a common trap to avoid. Thinking both fn calls share a single x. They don't. Each call opened its own fresh scope, so there were 2 independent x bindings, 3 in the inner call and 9 in the outer one. Finally, do twice can return. The body fn of n has collapsed to 81, so do twice returns 81, and its own scope disappears. Control lands back in the global environment and the print displays 81. So the 2 lambda evaluations, one for each fn in fn of n, wrapped the inner inside the outer. That is exactly what do twice was built to do. 3 rules carried the whole trace. First, every function call creates a fresh environment that maps parameters to arguments. Second, when a call contains another call, the outer one waits while the inner one is evaluated in its own scope. Then its value is substituted back. Third, names are resolved by looking upward to the nearest enclosing environment that actually knows the variable. Master those 3 moves, and you can hand trace any nested call, lambdas included, with confidence. To practice what you just learned, this course has free exercises and AI graded feedback on ludium.ai. The link is in the description.